Hi everyone, welcome to my YouTube channel Tech Data Engineer. So today we will see adaptive query executions. Okay, one of the important topic which basically used in productions. So this basically we are enabling or disabling when our job is not optimized, and that will take much time than required. So that time this is the part of optimizations basically. So we use adaptive query executions and all. Okay, so adaptive query execution in pyspark is a feature introduced in spark 3.0. So with earlier version this functionality was not there. So what basically it will do, it will enhance the executions of query plan by making them more dynamic. Okay, so what it will do, it initial level also it will store some statics, and based on that, like which data frame is higher, which data frame is bigger, which is smaller, what is the filter condition, how much data we have to read and all. So this all statics it will take at the initial level. Okay, then at the dynamic time also it will, based on the dynamic data, it will check the statics, and based on that it will execute the query. Okay, so what it will do, it will basically enhance the executions of query plan by making them more dynamic and adaptable to the actual data being processed. Okay, so here we will see key features of AQE. Okay, adaptive query execution. So what was the key features? First key features was dynamic optimizations. So how it will work basically, so adaptive query executions allow a spark to optimize query execution at runtime. Okay, so what I told, it will take the data at runtime, take all the statics. That means that instead of relying on static query plan. Okay, so that whatever the generated at during the initial compilations, so there are two phases. One is the initial time compilations where it will store all the statics. Spark can adjust the plan based on the data statics collected during runtime. Okay, so in dynamic optimization, what it will do, first it will store the data, that is the data is static time at the initial level. Then at the dynamic time, when it is running the job, it will store the data, and it will uh, plan accordingly based on that, you can say, dynamic time. Okay, then second point is re-optimizations. So so as a spark process data, so it can gather a static about the size of data being processed, which can leads to better decision for join strategy, partitioning, and other optimization. Suppose let us consider if a join operation is expected to involve large data set, but it is found to be much small. So spark can switch to a more efficient join strategy. Okay, so re-optimization means, so at initial level we find the data set with more, but runtime we can find that, oh, this data set is smaller. Then it will change the execution plan and re-optimize the strategy. Okay, so that was a feature of adaptive query execution. Then third was the join strategy and adjustment. So AQE basically supports different join strategy. You can say broadcast join, shuffle join. Okay, so if Spark detects that one of the table involved in a join operation is smaller enough, then what it will do, it can choose to broadcast the table at all node. Okay, so if it broadcast to all nodes, so what it will do, it will increase the efficiency, increase the time. Okay, so sorry, decrease the time. Okay, so it will increase the processing time. So it will decrease the processing time, and by sending the table to all the nodes, but it means like by broadcasting. Okay, simple term. Then the other functionalities, collage partitioning. Okay, collaging partitioning. So collaging is basically what, so it is a partition technique, collage and so what it will do basically, so if spark realize that stage produce a smaller number of partitions. Okay, so it can merge them into fewer partitions. Okay, so that reduce the overhead in subsequent stage and can improve the performance. So basically when it will realize that uh, stage produce a smaller number of partitions, so what it will do, it can merge them into a fewer partitions. Okay, so that way basically it will improve our uh, improve our optimizations. Then the other is dynamic partition pairing. So adaptive query executions can optimize query that involve filter conditions. Suppose there is a data set, and so there is a data set that have 1000 records. But in that data set, if you are filtering based on age is greater than 60, so now the data set reduced to 100 itself. So you don't have to read all the data, so that's why dynamic partition viewing. So in that case, AQE can optimize query that involve filter on partition data. So by evaluating filter at runtime, a Spark can avoid scanning the unnecessary partition. So you don't have to scan all the partitions. So wherever the data is there and the filter condition, it can scan that partitions only, and then it will proceed with further with the executions. Okay. Then the next point, how adaptive query execution work basically. So adaptive query executions have three query plan. Okay, first was the initial query plan. So in initial query plan, so whenever we whenever a Spark job is submitted, an initial query execution plan is created. Okay, so whenever you will submit your job, PySpark job you will submit, so initial query plan is executed created. Okay, this plan is based on the optimizer analysis and the statics available at that time. So this is basically the initial time where whatever the statics you have based on our optimizer, it will take the statics. Then what will happen after that? Execution and data collection. So at the as the query executed, Spark collects runtime statics about the data, such as number of rows processed and the size of intermediate result. So then it will take the execution and data collection. Then after that, at the runtime adjustment, what it will happen? So after the initial execution of some stage, like AQ evaluate the gather the statics, and if it is determined that adjustment are beneficial, so once they will take the initial query plan, then again execute and data collection. After that, if it will find that if there is adjustment are beneficial, then like joining a strategy or some other thing, then it can modify the execution plan for subsequent stage. So that way basically AQ will work to optimize our job. So if you are writing any PySpark job, how can you enable that? So you have to in spark.sql, first you have to import the Spark SQL, then from spark.sql, this all you can enable through your config file. Okay, if you have configuration file, so you can do that spark.sql adaptive enabled. So what it will do, it will basically enable or disable the AQE. It should be set to be true or false. Then now it comes to Spark SQL adaptive shuffle partition. So if you support partition, then they set the number of partition used when coalescing. And then similar way, Spark SQL adaptive join enabled. So if you enable this join, so it will at the dynamic time it will change the strategy. Okay, there is Spark SQL adaptive college partition enable. So enable the coalescing of partition based on the data size. So that way it will do. Now let us consider a use case, how it will help in like how it will help and how AQ is applied on that. So we have already created a Spark session, then I have created a Spark called Spark data enabled, then created a two data frame, a Spark data park with large data set, and this is a small data set. So how we know that df dot join df2? So what it will do, it will basically broadcast, because one data set is small. So in this example, if data df2 turns out to be small, so you can see that df2 turns out to small, so a Spark can automatically use a broadcast join to optimize the executions. Okay, so it will basically optimize, it will send this data frame to all the executor node, and that way it will help us to optimized our job. We can see certain more example also where our AQ will help to optimize the job, but for this video I have taken this simple example where we can showcase like how we are best how from AQ how we can optimize our job. Okay, thank you, thanks for watching.